Now, what's the relationship between the frameworks, the way they have been created in the very beginning, and the architectural style? Where whenever you implemented something with a framework, say, first of all, the most important thing that I see when implementing now applications, and I think back years ago how this used to be, is the create once, maintain continuously principle, which was the case of normal monolith, which means that in the case of a monolith, you created the application once, and then you might have continuously maintain it for many years. Doesn't matter how many years, but you only created it once. So a lot of the things, a lot of the capabilities, they only needed to be configured only once. Everything that came afterwards, a lot of the features that you implemented, they were relying on the configuration that somebody did at the very beginning, and then maybe that somebody isn't even there in the project anymore, but the developers will never even touch what is the backbone configuration of the monolith. So that's why in terms of a framework, Spring, as well as other frameworks like Java EE at that time was the name. Today it's called Jakarta EE, but Java EE at that time, they worked on the philosophy of a monolithic implementation, and in most of the cases they didn't care about the configuration, because everybody knew that the configuration is anyway is only one-time problem, and then you very rarely just have to change things on the configuration. Of course, you have to maintain continuously the application, which means you always add new features to your application, and you of course correct bugs if that's the case. But in terms of implementing the app, you only have to create it once. And that's a really important thing that's sticking on the monolithic style, and that's why when you now use what I call vanilla Spring, which is Spring without any kind of enhancement done like what Spring Boot does in terms of the Spring ecosystem project, Spring Boot we'll discuss later. Vanilla Spring, you just add it, and you add modules out of the Spring framework depending on what you need. Say you only need to have to use inversion of control, then you only add the Spring context dependency to your application. But if you would like to create a web app, then you add some more dependencies, and then you have to configure your web app. For example, if you want to configure a web app with Spring, then you have to configure first of all, you need a servlet container. Say we exclude now reactive applications. We discuss about the standard ones, because that's anyway what has been there in the early ages of software development implementations. We have to configure a servlet container like Tomcat or Jetty or something similar. Then we have to configure the Spring MVC components, which are the dispatcher servlet, the handler mapping, the view resolver. You have to write a lot of configurations. I'm not sure how many of you really have seen and know what I mean here, but trust me, when I was teaching Spring 3 not many years ago, maybe 6-7 years ago, I can't remember precisely, and at that time Spring 3, maybe 4, still Spring Boot wasn't the way to go. One of the lessons was implementing web apps with Spring, of course, because in a lot of cases with Spring we implement web applications. It was about 30-40 minutes of work to configure a web application in a class of 20 people. And that's something that both my students and I hated. It's a long way and nobody cared, because that's anyway something in case of a monolithic app you would have only done once. So that's why nobody cared about, up to the point where with the software evolution, developers splitted applications into services, the way we'll see later. In case of a monolith, the main things that influenced also the way the frameworks looked like Spring in our case is the main topic of the discussion. But again, most of the things I discussed here, they influenced all of the frameworks, is the fact that high scalability, first of all, was not a goal. So that means that when you design a monolith, you don't think about it being able to quickly spin up and down and like just create one more instance immediately to be able to scale it horizontally. Usually it was implemented just like one process in only on only one system. You didn't have multiple processes of the multiple instances of the same process launch. There wasn't a cloud at that time. We didn't use availability zones. So if there were multiple, say, instances when we had a load balancer, the only way to go to avoid statefulness was using, for example, sticky sessions, or maybe we were using blackboarding in terms of keeping the data that's shared among instances. If there were multiple instances, but at the very beginning you didn't even have multiple instances. So that's why when we think about monoliths, high scalability is not a goal, not for the monolithic architecture. The communication is less of a problem. When I say communication, I refer to communication in the network. Because when you have a monolithic applications, the features, you always implement one more feature, just adding it into the same artifact, into the same executable artifact, or as a new module, if you actually are lucky enough to have a modular monolith. But in my experience, lots of the monoliths from the early ages I had to deal with, they weren't actually modular, and that's again because of the fact that the main principles for creating clean architectures and clean code in general and clean applications came years during the next years. So communication is less of a problem in case of a monolith, because you don't actually have communication in the network. You have all the features all together inside only one application, and then they already communicate one to the other, the features inside the same process. So you don't have to care about what happens if the network is unreliable. Mind what I said at the beginning of our today's discussion is that the one of the facts why monolithic architecture, the monolithic architectural style was the main way to implement apps years ago, was because the network wasn't at all the same reliable as it is today. Of course, neither today we consider the network to be 100% reliable. That's one of the main cloud development principles, take into consideration that the network is not 100% reliable. But now when we say is not 100% reliable, when we discuss today about reliability and availability, now we discuss in number of nines. You've maybe heard the expression 9 nines or 6 nines or 4 nines. What's that? It means how many nines after the decimal point you have after 99. So when we discuss now about availability or reliability, is 99.9999 4 nines or 6 nines or 9 nines. The more nines you have, the closer you are to 100%. But now only if you think of the way in which we now count the availability, you can think of the difference between the way we implement today's applications and how they were taught at the very beginning, because there was not something like counting in 9 nines or 4 nines or 6 nines, not even 2 nines 30 years ago or 20 years ago. So you didn't have a chance to discuss about having multiple services, because you couldn't call one the other same reliable as you do today. So even if today we say the network is not 100% reliable, it's reliable enough to be able to have services. So communication is not a problem, but communication wasn't even thought into consideration at that time. And let's security concerns also from the fact that you have less communication. You definitely have less security concerns, because definitely now when you have a monolith, years ago you don't send information here and there a lot, so the information stays in most of the cases inside one app, so it's less probable to be stolen than it is today, when you actually send that most of the functionalities of the software capabilities we implement today, they rely on apps communicating one with the other. So you send information here and there, and you store information, so you have data at rest, you have data in transition, and both of them, data at rest and data in transition, they have to be they have to be secured. And now it's a concern. It became with time a very important concern, and now security really is one of the first concerns you actually have with any application. That's what you will find, actually, one of the things I've written in the first pages of my Spring Security in Action. And it's in the first pages of the book just because it's so important to know. In the first chapter, in the very first pages, in the main important principles of what software security is and how you implement it in a Spring application. So how do frameworks respond to this architectural style? What's the response of a framework? Spring in general, but again, that's the way you will see the old Java Enterpriseation. I added the Java EE logo there. That's because Java EE was at that time the framework. But of course now the name is Jakarta EE. It has been now open sourced. It's a lot of story we don't have to discuss now. But considering how the framework respond to that, first of all, the IOC container functionality is firstly was linked to the server. That means basically the server where the application was implemented. So the server itself was the one to also serve the inversion of control functionality for your application. And now I would like you to think about if you ever seen that, if you just started with implementing software and you are not old enough to have seen this. I actually feel old now. I actually feel like I know who was that in Lord of the Rings saying I was there Gandalf 3,000 years ago. Yeah, that's the way I'm now feeling. But I've been there 3,000 years ago, or whatever that is. That was. And I've seen a lot of applications implemented with Java EE and with implementations of the Java EE specifications like AJBs, Enterprise Java Beans, and all the others around. And how you actually worked with implementing a Java EE app was to deploy your artifact, your executable, in what we still call, of course, because there still exists, application servers. And application servers examples are Glassfish, WebSphere, WebLogic. They were processes able to control your Java EE implementation. So you just deployed your application. That's how we call it. We deployed it into an application server. It's like putting it in this application server to be managed by this application server, and the management is from the application server itself. And if you think a little bit about this, you will see that this is basically a very monolithic style of working, and that's because is mirroring precisely what you had at that time, monoliths. Application servers are the way we understand now monolithic applications, because they actually even forced you to have the same server in which you deployed multiple applications. So do you see how much monolithic they are? This kind of philosophy is what we actually had at that time, and it's mirroring the time when they appeared. Application servers appeared when software was still implemented mostly monolithic, and they are themselves monolithic. You have multiple apps. Instead of separating them, you are actually doing the opposite. You are putting them and deploying them into the same instance of application server. And that's why I said the inversion of control container functionality started first as being offered by the server itself. In case of, for example, an application server, it was the application server itself providing the functionality of the IOC. So the framework itself was only for implementing the business logic and always relying on this monolithic block application server to obtain part of the capabilities it needed, like transactionability, like logging, like inversion of control. And then we have the plain configuration with no convention. That's also a response of how frameworks have been implemented. And again, what does that mean is what I was mentioning a little bit earlier in my presentation. The fact that you actually had to configure everything. You have no configuration. The framework is something providing you plenty of capabilities that you don't have to rewrite because they are mostly the same in no matter what kind of business logic you implement. That's, I've said at the very beginning of this presentation, that's where they came from. That's how they appeared. Frameworks appeared because developers had to write a lot of things, a lot of capabilities the same way for most applications, and it wasn't an intelligent idea to do that. But frameworks didn't start by providing any kind of convention. And the reason they didn't implement any kind of convention is because you didn't have where to take a convention from, actually. Because we are so early into the stages of software development that you don't have a convention. In order to have a convention, how do you get a convention? So how do you know what is a convention actually? Is a group of accepted solutions as being the best by a group. So when a group decides that something is the best, you have some principles. Principles are the same way. Some techniques that a specific group accepts as being the best. But now you are at the very beginning, so how can you say what's best? Because you don't have the experience you don't have so many technologies, first of all. You don't have principles, so you don't have techniques to take into consideration, is it? So then where should you take a convention from in this case? You don't have. So you have plain configurations. Developers have capabilities, which is better than using vanilla language, but you don't have a convention because you don't have where to take a convention from. And then, of course, a lot of people know, and even fresh starters with the technology here now and then, about XML configurations, the external declarative configuration, the declarative configurations, which mean whatever you were configuring for your application, for example, in case of a specific framework, you are declaring one or more XML files, sometimes referring one to the other. And that was the main way in which you were specifying different configurations for any framework. And most of the frameworks that are old enough to have seen those times, they have seen, and they even do still support using external declarative configurations. You will see here Spring started with external declarative configurations. First Spring applications and those that have been started years ago even still have XML configuration files. That's where we were declaring the beans. That's where we were declaring the aspects. That's where we were declaring security and Spring security configurations, because Spring security is old enough to have seen as well XML external declarative configurations. That's because, of course, you didn't have, first of all, the needed things in the language to implement. That's one of the reasons, is that we use to now, what we use today, which is annotations, started with Java 5. But even after Java 5, that's not the main reason why XML configurations have been there at the very beginning. But it's still the monolithic architectural style. Think about it. Why is a monolithic architectural style, which was the main used style years ago, when we discussed now also about the start of the Spring and other frameworks, why was that actually a reason of using external declarative configurations? Because when we build monolithic applications and when we start monolithic applications, it takes a lot of time. I've seen monoliths for which the compilation last 1 hour. I've seen monoliths that were starting in 30 minutes, only starting in 30 minutes. So guess what you'd like not to do when you have to change a configuration if you have a big monolithic application? You don't want to recompile. You don't want that. You want to be able to change a configuration as much as possible without being needed to recompile the application. And that's a great achievement, to be able to change a configuration where something is not ready without needing to recompile the app, because recompiling the app takes too much time. The XML, and the reason why the first versions of application frameworks like Spring and Java EE used XML and Hibernate as well, and JSF, which is also part of Java EE. And when I say Java EE, I don't necessarily refer to HGBs, I refer to JSF and to all the others. Why they were using XML at the very beginning? Not necessarily because of the language capability. Of course, that was one of the reasons, language capability, because we didn't have annotations from the very beginning. But the main reason really is, with XML, you can change the configuration and you don't have to rebuild the app. With annotations, you actually have to rebuild the app, but you will see why later. Annotations became a better idea, but that's only with software evolution and with software architecture evolution. Because now we are using service-oriented architectures. And even more particularly, we are using microservices. And microservices are designed to start fast, to be as small as possible, to implement only one responsibility if possible. Of course, that's another discussion, architectural discussion of what a responsibility means in a microservice. But the whole idea is that you won't see a microservice that needs 1 hour to start, because if you see a microservice starting in 1 hour, then that shouldn't be considered a microservice, probably. I'm not sure what it is, but not a microservice. That's how frameworks respond.